Paper of the day is Accelerating Relational Databases by Leveraging Remote Memory and RDMA. This paper considered the setting of a cluster of RDBMS servers connected with RDMA-enabled NICs, where some servers are experiencing memory pressure while other servers have available memory. Paper presented the abstraction of exposing unused memory on remote servers using a lightweight file API that allows a mature and SMP, which stands for Symmetric Multiprocessing RDBMS, to significantly improve performance of memory-intensive workloads with modest changes to the RDBMS engine. Authors implemented this remote memory abstraction in Microsoft SQL Server and demonstrated the potential performance benefits using a variety of configurations and a combination of micro benchmarks, as well as the industry standard TPC benchmarks. Compared to using disks when memory is insufficient, our abstraction improved the throughput and latency of queries with short reads and writes by 3x to 10x, while improving the latency of multiple TPC-H and TPC-DS queries by 2 times or even 100 times. Now let's look at the evaluation. Paper measures native performance of the I/O subsystems and the remote memory access using a standard benchmark, SQL I/O. They use a range scan workload to micro-benchmark buffer pool scenarios of extension and priming, and a hash plus sort workload, which is designed to stress tempDB by generating temporary data with hash and sort operations on large amount of data. They also use a number of standard benchmark workloads, 2 decision support benchmarks, TPC-H and TPC-DS, and one online transaction processing benchmark, TPCC. Coming to contributions, there are 4 key contributions. First, authors study the novel problem of how an SMP RDBMS can leverage RDMA and available remote memory in a cluster. Second, they abstract remote memory accessed via RDMA as a lightweight file API. This abstraction enables easy integration of remote memory into existing RDBMS and is flexible enough to support 4 novel scenarios that significantly improve performance of memory-intensive workloads. Third, they articulate and address several crucial design challenges to efficiently support this abstraction in a mature RDBMS. Fourth, they implement this abstraction and scenarios in Microsoft SQL Server and conduct extensive experiments to quantify the benefits using targeted micro benchmarks as well as the industry standard benchmark workloads. Now let's give this paper a PS score. Overall, it's really nice and long read, so it gets 7 out of 10 on readability. With 16 pages long, it scores 7 out of 10 on length. Reproducibility and repeatability will be challenging, so it gets 6 out of 10. Industry value and learning meter is high, so it gets 9 out of 10 on each. Overall PS score is 8 out of 10.